Welcome to Quantitative Literacy. Our first lesson, section 1.1, is called Giving 110%. Basically, it's just on percents. So, we're going to look at some examples here. It says, using the fact that percent means per 100, write 84% and 9% as fractions with the denominator of 100. So, 84% would be 84 over 100, and 9% would be 9 over 100. And those are considered equivalent. For number 2, we want to convert each percent to a fraction and make sure you write it in lowest terms. So the first one, we're going to write 42% as 42 over 100. And then we need to reduce it. Okay, so we know that 2 will go into both 42 and 100. So we're going to divide them both by 2. So we're essentially dividing by 1, which is allowed because we're dividing by 2 over 2, which is 1. So we get 21 over 50, and that's reduced as far as it can go. For B, 37.5%. Well, first of all, we can't have fractions in a fraction. That's just not nice. So, first thing we're going to do is get rid of our fraction there, that 1/2. And to get rid of a 1/2, we can just multiply by 2. So we're going to multiply both the top and the bottom by 2. 37.5 times 2 is 75. And 100 times 2 is 200. That will reduce some more. Both of those are divisible by 25. So we get 3 over 8 are our fractions reduced. If I switch from slide to slide too fast, you can always pause or back up, rewind, and look at it further if you need. For number 3, we know that we can write 12% as a fraction in the form 12 over 100 and 72% in the form 72 over 100. Use a calculator to perform the division in each case, writing the original percent in decimal form. So 12% is the same as 12 over 100. And if we use a calculator, it changes it to 0.12 or 12 hundredths. 72% is the same as 72 over 100, and using a calculator it changes it to 0.72. So if you'll notice here that our 12% became 0.12. What happened? Our decimal moved 2 places to the left. Same thing here, our decimal moved 2 places to the left. Okay? And that allowed us to turn a percent into a decimal. So that's going to be important for us. So this time we're going to, well, first we've got a little statement to fill out. It says, to convert a percent to a decimal, drop the percent sign and move the decimal point 2 places to the left. And then we're going to write each of these in percent form. So 41%, to change that to a decimal, we're going to move the decimal 2 places to the left, and that gives us 0.41. For 6.7%, move the decimal 2 places to the left, and when we do that this time, we have to put something in place there. We put a 0 in front of the 6. Then 120%, move the decimal to the left 2 places, and we end up with 1.20, or just 1.2. The opposite of moving the decimal 2 places to the left is moving the decimal 2 places to the right. The opposite of dropping the percent sign is adding the percent sign. So it says, write a procedure for converting a decimal to percent form and then use it to convert these. So our procedure would be to convert a decimal to percent form, move the decimal 2 places to the right, and add a percent sign. So to change 0.34, we'll move our decimal 2 places to the right, and that gives us 34. And add back our percent. 0.07, move the decimal 2 places to the right, and that'll give us just 7%. We don't want to leave the 0 in front there. That doesn't make sense. And 1.658, move it 2 places to the right, and we have 165.8%. A restaurant was running a fundraiser tonight for the local food bank in which 30% of every purchase was donated for food relief. If my wife and I spent $24.59 at the restaurant, how much was donated? So what we're going to do is the calculation, it'll be 30% of $24.59. So 30% of $24.59 is what amount? When we're talking about ofs, we're actually talking about multiplication. So 30%, we've changed our percent to a decimal, times 24.59 is 7.377. So that means that $7.38 is donated for their purchase. Same idea can be used for other calculations, like this one. A closeout store is advertising leather jackets at 70% off the original price, which means that the sale price is 30% of the original price. So notice what they did there. If your jacket is 70% off, then your new price is 100 minus 70, or 30% of the original price. So that makes things easier when you're at the store, just to subtract from 100, and then you don't have to worry about subtracting a number from the original price later on. So we want 30% of what amount is $59. So 30%, or 0.3, of what amount? Well, we don't know what, so we're going to call it X, is 59. To solve this, divide both sides by 3. Yes, you still have to be able to solve for X in this class. And we get $196.67. was the original cost for the jacket. The same idea can be used to find the percentage, but it's more straightforward to use division. For example, of the 32 teams in the National Football League, 12 make the playoffs each year. So what percentage make the playoffs? Well, 12 out of 32. So 12 out of, that's division, 32, like that. And we can change that to a decimal just by dividing, and then we can change it to a percent by moving our decimal 2 places to the right. This says my wife, not my wife, but whoever wrote this book, I suppose, is an absolute wizard with Macy's coupons. As a high volume shopper she gets quite a few coupons in the mail. On one recent mall outing, she found a lovely red strapless number with a selling price of $79. She had 2 coupons to choose from. One offers $15 off any purchase of $50 or more. The other offers 20% off any item. So which is the better choice? Well, if we find 20% of 79, change 20% to a decimal, multiply times 79, that gives us $15.80. So if she chose the 20% off coupon, that's what she would pay. If we chose the $15 off, oh, that was supposed to be 79. Then it would be we don't even need to do that, do we? If we choose the $15 off, then we get $15 off. The 20% gives us $15.80 off. So the 20% off is better because we save a whole 80% or 80 cents, which is better than nothing. The sales tax in our county is 6.5%. Find the amount of tax on the dress purchase after applying the coupon. So tax is figured after the coupon is used, so that's good. So the cost of the dress will be the original price minus the discount, so $63.20. And so the tax is 6.5% or 0.065 of $63.20. That's $4.11. So if we take our cost, our discounted price, and add on the tax, then our final price will be $67.31. It's common for stores to advertise a certain percentage off, then say discount is reflected in the marked price, leaving you to trust that you're getting the percent off they claimed. Suppose that a refrigerator is listed as 30% off with a sale price of $749. What would that make the original selling price? Okay, so if it's 30% off, that's the same thing as the cost being 100 minus 30, or 70% of the original price. So we know that $749 is 70% of the original price. So 70% of what, we'll just make it X, is 749. Divide both sides by 0.7. And that means that the original price was $1,070. So if you go to the store a couple weeks later and they've got the discount off and it's less than $1,070 or $1,070, then you know they were joking or lying. On July 24, 2009, the federal minimum wage was raised from $6.55 to $7.25. Find the percent increase. Okay, so this is a formula that's important to us. Percent increase is the new amount minus the original amount over the original amount. Okay? That's how we find percent increase. So the percent increase would be the new amount, that's $725, minus the original, $655, divided by the original, $655. We'll subtract first, that gives us 0.7. And then divide by 6.55, and we get 0.107. So that means that the minimum wage was raised by 10.7%. Sometimes in this class you're going to be asked to use Excel or a similar spreadsheet material. So what we're looking at here is when we use Excel, it does things like formulas for us. If we put them in, it creates a formula for us. So you can see that this particular cell right here, it shows up here which formula it's using. It's using C3 divided by A3. Well, C3 is this, and A3 is here. Notice C3, A3. And so it's actually, to get this amount, they're actually dividing 0.7 by 6.55. Okay? So what we've been asked to do here is write the formulas that appear in cells C3 and D2. So C3 is here. And so what happened to get C3? Let's see. It looks like if we take 7.25 and subtract 6.55, then we get 0.7. So put that in your calculator, you'll see that's true. So what's actually happened is we took cell B3 and subtracted cell A3, and that gave us cell C3. To get D2, here is D2. What do we think might have happened? Well, if we try some things out, if you look at C2, let's see, a decimal percent change would be the amount of the change, so new minus original, over the original. So the amount of the change is right here, and your original amount was right here. So it should be C2 divided by A2, and that is the case. And so that's just a little introduction to spreadsheets there. In promotional materials, a company that increased their workforce from 1,000 to 1,500 workers claimed that they hired 50% more workers. A rival of theirs bragged about decreasing emissions from 1,500 to 1,000 cubic feet per day, claiming a 33% reduction. Which company is lying? Well, it certainly looks like they'd be lying, because 1,000 to 1,500 is 50%, but going down from 1,500 to 1,000 is 33. That doesn't seem quite right, does it? But let's see. So, if we go with 1,000 to 1,500, the percent change would be the new minus the original over the original. That's 500 over 1,000, or 0.5, which is 50%. So the first company is telling the truth. So let's look at the second one. What about 1,500 to 1,000? The percent increase here is actually going to be a decrease. That's okay. We'll just get a negative number. So new minus original over the original gives us a negative 500 over 1,500, which is, when you put that in your calculator, negative 0.33, or negative 33%. Now, when we have negatives, a lot of times in these, actual real-world problems here, we're not going to say that the company increased by negative 30%, or that it decreased by negative 30%. Decreased by negative would be a double negative, so that's not going to work at all. But we'll just say that they decreased by 33%, and the decreased by is taking care of your negative there. So it looks like the second one's claim is correct. So both are telling the truth. So even though it didn't appear it from what it looks like, it is the case that both are correct. Okay, a few more here. Many people probably think that those who are good at math always do exact calculations. But estimation is actually a really useful tool, especially when it comes to things like percent discount. Suppose that you're shopping on a rack that offers 40% off the lowest ticket price, and you're interested in a sweater with a ticket price of $47.99. Given that 40% is being subtracted from the ticket price, explain why that makes the sale price 60% of the ticket price. So we've discussed this before. If we take 100% and subtract 40%, the percent off, then that leaves us with the percent that's left is 60%. Okay? So the ticket price can be rounded easily to $50, right? Yeah, it's a little bit more, but it's pretty close, and you're always going to have to look at tax there too. So rounding up is a good idea. So you can estimate the sale price by multiplying 50 times 0.6. The easy way to do this is in your head. I'm going to do it on paper here, but in your head you can probably multiply 50 by 6 pretty quickly. You get 300. Okay? And then move the decimal a place to the left. Because here we've moved a decimal to the right to change, so we'd move it to the left to change there. And so that tells us that 50 times 0.6 is actually 30. So we can estimate that the cost of the sweater is about $30. And again, is that the exact cost? No. But that's enough to determine if you can afford it, right? Oh, okay. Never mind. I thought it was asking the same question again. Okay. Now use the procedures we reviewed in this lesson to find the exact discount price. Okay. So we would take 60% of $47.99, and that gives us $28.49. So would your estimate have been good enough? Yes. It would let me know if I could afford it. Okay. While shopping at Nordstrom, you pick out, gosh, I've never been shopping at Nordstrom. It's too expensive for me. Anyway, while shopping at Nordstrom, you pick out 2 pairs of jeans at $49 each. Well, that's not bad. And a pair of shoes on sale for $39. Pretty good too. Then you splurge on a $95 sweater. Oh, yeah. You have 2 coupons but can only use one. The first offers 40% off any single item. The second offers 15% off your entire purchase. So which is better? Well, if we look first at 40%, off one item, then that means it's 60% of the original cost, right? So we want to take 65% off the jeans, right? No, we want to take, if it's off one item, we want to make sure we're taking the 60% off, and I wrote that 65 for some reason, of the most expensive item, which is the sweater. So the sweater would end up being $57, okay? That would put our total at $57 for the sweater. Each pair of jeans was $49, and the shoes for $39. Gives us a total of $194. Okay, let's compare that to what if we take 15% off the entire purchase. Okay, so that means our cost is going to be 85% off of, or 85% of the original price. So the original price of all these was $49 for each pair of jeans, $39 for the shoes, and $95 for the sweater. $232. So we take 15% of $232 and we get $197.20. So it looks like in this case we are better off using the 40% off the single item. And that concludes our very first section of quantitative literacy.